I'm going to be showing you how to set up the code and how the code actually goes along with wiring up the circuit, and then I'll go ahead and wire it up and show you guys that. It is thunderstorming currently, so if you hear some of that in the background, I'm sorry. I'm probably not going to take the time to edit that out, but in the event that it bothers you, I do apologize. So, first things first, we are going to have to declare some variables here. So, I'm just going to go ahead and open up the Arduino IDE. That's what's open here, and connect to the Arduino Uno, which is what I said to order. Although after some more research, I am going to make a Pico W video, as it's actually looking like it might be a little bit cheaper to do, and you can have your own localhost website and then use Cloudflare to tunnel in and stuff like that. So I'm going to make another series of exactly this, but with the Pico for the Raspberry Pi version of this. Okay, so let's declare some constants. So we have some numbers that we need to declare of the properties of like dry, very dry, damp, wet, stuff like that. So let's go ahead and do very dry, and we will say that's going to be equal to 600. Now I already looked at the variables on this and like what they read, but I'll go ahead and show you guys that and stuff as well. So now I'm just going to copy and paste this and then just, constant, and then we need to give it data type long. So it's long data, which is essentially just like a long number. We'll do dry, damp, wet. Okay, so wet, damp, and I'll just make that one just dry. Okay, so we can use those for our if statements later. That's all really that is. And then we need to declare our pumps, and I like to also declare what we're using as testers. So if you're going to use the analog inputs, or you can use those also as an output if you want to. I'll show you that. I'll just do all analog stuff for right now. You're going to use character, and then I'll say, let's do pump 1 is going to be equal to A0. Okay, so we're going to put the pump 1 on the A0 circuit. That's going to open close the relay. And then we'll do another one that's going to be character, and this one's going to be sensor 1. I don't know if my syntax is correct on C++. I mainly code in Python, but in the event that it's completely wrong, I apologize, but I'm just going to keep coding the way I code. So that one's going to be A1. So in the event that you want it to be a pin on the digital side, instead of putting character here, you would just change this to int, and then you just say whatever number the pin is. So it goes from 0 is receive, 1 is transmit, and then 2 is your first actual pin that you can utilize for the digital. That's not receive and transmit and designated for those. But for this, we're just going to use the characters. So next, we're going to set up our serial monitor. So we're going to do serial dot begin, and this one's going to be 9600 and semicolon. Okay, don't forget your semicolons, or else you just have to code a little bit more, and that sucks. So then we need to declare our pin modes. Pin mode. So for this, it just goes as you declare what pin you're using, and you declare if it's an input or an output. So an input would be like reading electricity given to it. So like our sensors work in a way where if they get wet, they're going to transmit less electricity, I believe, and then more if it's dry. Speaking of, we should probably change these values. 600 550. We'll go through on how I actually got these values. I'll do this one 500 and this one 400. Okay, so the pin mode for this one is going to be pump 1 is going to be in output, because that's going to be us giving electricity to say, hey, you need to open and close this relay. And then we're going to do pin mode, case sensitive, I believe. And this one's going to be sensor 1, and that one is going to be input, because we want to read that. So then I'm going to put a delay in here so that it has time to set everything up. I'll just put a little 5-second delay. That's in milliseconds. And now we need to write our loop. So this just continuously runs unless you say stop or exit the program, whatever you want to do. So right off the bat, I would like to do an if statement. So we're going to do if, well, actually, we can't really do our if statement. We need to read the sensor first, right? That's the very first thing to do, because our if statement is really dependent on the sensor. So I'm going to make an integer, and I'm going to call it sensor value 1, okay? And that's going to be equal to analog read, and that's going to be of sensor 1, okay? Now, if you do not put that sensor 1 is an input here up top, analog read doesn't really care. It's still going to read that input. But if you tell it to do an output and you don't put it up there, you're not going to have any luck getting that output. So int is sensor value 1. And after that, we're going to serial, to put it in the serial monitor, print ln, not in. This way it prints on a new line every time, so you can actually read the thing. And we're going to say print out sensor value 1. Okay. Now, I am going to compile this, and I missed a semicolon as per usual. And then I'm going to go ahead and run it. And now my current Arduino is actually not set up to anything. So it's actually not going to give us anything on the serial monitor. But to get to the serial monitor, we go to the Tools tab up here at the top, and then click Serial Monitor. And that will give us our readings. Now, obviously, there's nothing here. If I was to comment this out, oh, there it is. So anyways, there's nothing there. It waits that 5-second delay. We'll turn that down to 3. So you can see that it's saying 276, 275 the entire time. I don't have the thing plugged in right now, so that's the very lowest value that it can give you. That's why it's doing that. But we don't want it to spam us, so I'm going to hit delay and then give it, I don't know, a full second on the delay. And then I'm going to hit recompile and re-upload that. Go back to our serial monitor tab here. I'm going to clear it. And now it's printing it out again. 3, 3, 3, 3, yada, yada, yada. Okay. So now I'm going to set one up really quickly. So I have the breadboard. Bring this over. And what did I set this up to? I set it up to sensor 1 is going into A1. So, put this back in the negative. Putting the ground in first so we don't short circuit anything. And then I'm going to put in the positive. That's going to be 5 volts. And then after that, I'm going to add in the A1 to the A out on the sensor, is what it's called. So you can see those values change now. The sensor is very dry right now. I have not put it in any water. Now I'm going to grab a glass of water and I'm going to dunk it in. Okay, so we are currently very dry, and now I'm going to dunk it in the water. You don't want to go past halfway at the sensor. You can see the value drops to 300, 290s. So that is wet. Obviously, you don't want your your soil to just be water. So getting down to 300 would really be awful for your plants. Unless you're doing hydroponics, then that's fine, obviously. But you probably don't want to do that with your plants. So I just took it out, as you could probably decipher. So it is still wet on the outside, but it's now reading up to 500s. So that would be damp, because it's not completely dry, but it's not wet. So that's how I got the values before. Obviously, I played with this a little bit before I showed you guys it. Don't want to look like an idiot. So that's just the honest truth. So here we go on the next one. We need our if statement. So we want to say if our sensor value uh, 1 is greater than, so it's going to be more dry than, let's say 500, and we want to do the following. And what do we want to do? We want to trigger the pump to pump in some water, right? So what we're going to say now is digital, or sorry, we don't want to do digital. Digital would be if we're doing one of the digital pins, but we're not doing one of the digital pins. We're doing an analog pin, right? But that actually doesn't matter. We're still doing digital right. So digital right, comma, or sorry, open, close paren. And then we're going to put in our pump. Okay, so we want to do pump 1, pump 1. And we want that to pump out high. So you can just say high and low. That'll be kind of a 0 and a 1, same effect, right? And that's going to turn on the pump. Now, this is going to loop. So once we write to this pump to say, yeah, turn on, it's stuck on. There's nothing saying, hey, you need to stop, right? So unless you want this to stay on forever, you need to turn it off at some point. So I'm just going to copy this, copy, paste, low. Okay, so now we have our pump turn on, and then immediately after it turns off, which obviously we don't want that either. So I'm going to go ahead and copy the delay, and let's say 5 seconds. So 5,000 milliseconds is probably pretty good, right? So we're going to turn on our pump, then we're going to turn it off if it is drier than 500. Okay, so we can do something like take the serial print and go to, I need to get rid of these extra spaces. So instead of the sensor value, I'm just going to print pump on and pump off. Okay, now I'm going to compile that. I'm going to send it on its way. Now, obviously, I'm going to clear this. Obviously, the pump isn't actually going to turn on, as the pump's not even in anything. But, it's just saying it is. So you can see pump on, pump off, pump on, pump off. I'm going to dip the sensor soil back in. There, it's back in now. So now you see it's 268, blah, blah, blah. Now it's reading it every second because this if statement does not fire off. So if we wanted to, we could say else. And then we can do another serial print and say that thing is, wet. All right, compile, upload, serial monitor. Let's clear that out again. And wet, wet, wet. Okay, so that's how it works. So now I'm going to go set up the entire thing and show you the different ways that you can actually use this and pump in some water into the soil. point, I'm coming back, adding the LED built-in output, and I'm also going to put in or change the values when the pump is on versus off. I'm going to go ahead and add these in. Just make it easier to kind of detect when the pump's going on and off. And then I'll make sure that this is automatically set to low. Okay, so now I'm going to add in a bunch of semicolons I forgot to add in on line 16. Oh, before line 16. Compile, upload, serial monitor, clear it out. Okay, so right now there is one LED on board that is on. We are determining wet. I need to grab another sensor. I have it here. There is now a yellow LED on, and the yellow LED is off. Now it's on. Okay, so there's now a yellow LED going on and off with the pump. Okay, so now that is good. I want to keep that.
So if you notice here the lights are flickering on and off, there is a lack of current. The 9-volt does not supply what the board needs to feed the relay properly.
Okay, I'm going to change the pump 1 here to pin 11. And hopefully that'll fix our issue. So because we used the pump 1, I don't have to go and find everywhere where we said pump 1 and change the pin. You can just change it right here at the top. That's just kind of why we do things like that. Just keeps it better, more maintainable. Sorry, excuse the sneeze. I'll edit that out. Or maybe I'll just make it even louder. That kind of sounds better. Okay, so I'm going to verify that, and then I'm going to upload that. And now I'm done uploading. So now I'm going to unplug and test it out again. Pin 11. Looks like it got a little clogged. Still watering. And it stopped. It successfully detected the water. So you might want to strategically place these, or just turn your water cycle on more. Just unplugged it.